Welcome back to Cerebral Valley. I'm here with Max Child and James Wilsterman, my friends and co-founders of Volley. This episode, we are talking about chips and big tech. My interview after a conversation with Max and James is with Chris Miller, the author of Chip War, the fight for the world's most critical technology. He is an expert. We talk a lot about NVIDIA. So stick around for that. Max, James, welcome back.
Nice to be here.
Hey, Eric, glad to be here.
The starting point question that I wanted to frame things up with is, do you think GPU capacity, the quality of these graphics processing units and what NVIDIA is putting out is the main driver for the sort of generative AI revolution we're seeing right now? Or do you mostly attribute it to the research papers, the new approaches? Who do you give credit?
I guess I give more credit to the research papers. Not that I don't discount what NVIDIA has done here. I think they were in the right place at the right time with the right technology to accelerate what was possible due to the research. But yeah, the research was the breakthrough.
I do think there was some intentionality. I mean, it's always hard to tell with AI when there's so much, it's a hypey thing to talk about. And this is a CEO that also made a bunch of money off crypto mining. So happy to dive into wild speculation, clearly. I don't know, Max, do you have a take here?
I mean, I think I agree with James. I just think that, even 4 or 5 years ago, we were already starting to see the beginnings of this with GPT-2 and, earlier versions of the foundational models, right? Also in areas outside of large language models, you saw big progress in, our hobby horses of speech synthesis, speech recognition, and other areas. So I think that even with 5-year-old GPUs, you still could do pretty cool stuff with the new research that was out, right? Whereas if the research never comes out, I don't think that you're making this kind of progress in any of these kind of large language model areas that or any of these areas of the stack that we've seen so far. So,
right. I mean, chips, even though there's potentially exponential improvement, it's still on a trajectory, whereas a paper sort of comes out of nowhere, gives people a new approach, and then sort of revolutionizes what's possible.
I mean, I think a different way to think about it would be okay, GPT has gotten 1,000 times better in the last 3 years, and the chips haven't gotten 1,000 times better in the last 3 years. So what's driving that? It's probably the software and then the people figuring out how to make GPT, right? So I just think it's clearly based on the ideas and the software. The chips are great, no doubt, but it's not the key driver.
I do think it. So NVIDIA has clearly gotten rich off this stuff. It is now a $1.1 trillion company. In 1 year, the stock is up 258%. And in 5 years, it's up 564%. So this has been a great run for the company. I mean, what do you guys make of NVIDIA investing in all these companies? I mean, similarly, it fits into, Amazon, Google, all these companies are making investments. The money that they're spending obviously comes back to their business, right? NVIDIA wants AI to be super active, so it puts out money that gets spent on NVIDIA chips. What do you make of, I mean, it's round tripping it's, spending money to make money, but it doesn't seem as sort of negative as in some cases.
I mean, isn't the investment NVIDIA is putting out into the ecosystem a rounding error compared to their revenue or compared to their profits? I mean, I think that they're making such ludicrous quantities of money that kicking back 1% to 2% into the startup community that might invest in NVIDIA chips in the future is obviously just a very good business practice.
Right. Well, it seems like they're literally playing kingmaker, right? I mean, companies like CoreWeave and who are sort of doing chip adjacent stuff depend on their access to H100s. And a lot of these foundation models seem like they're fundraising on the premise that, hey, we have access. This is differentiated partially because we have the deal to get GPU access when other people don't. And so there's this hope that, you have a moat in that you have access to chips that other people don't.
The scarcity today of the best-in-class chip, the H100, has to be a temporary situation. I just the economics of making more of these chips is a very good idea for NVIDIA, so they're going to do it. But
They clearly want to build like a Amazon Web Services type competitor, and so having eyes and ears in a bunch of startups and seeing maybe who they could acquire to do that is smart.
I do think the interesting question again is like Intel basically had like 2 decades of like total monopolistic dominance of PC chips, right? And the reason basically was that it's like really, really, really hard to build fabrication plants to build CPUs. And it took a long time for like TSMC and other people to sort of catch up on that front and then eventually kind of surpass them in many ways. But the question, I guess, for GPUs, I think, is like, is it that technically hard to make GPUs that like whatever the next version of the H100 is, you know, that they're going to be onto that before anyone's even caught up to the H100, and so they'll have this insurmountable 2 to 3 year advantage where if you want the best AI GPUs, it's always going to be NVIDIA for the next 20 years. Because that seems like a plausible case to me.
Do you think Microsoft was smart to invest $10 billion in OpenAI, given it's clearly going to distract the company, as has been reported? I think my friend in the Wall Street Journal reported as much, that they directed sort of their attention to OpenAI away from Microsoft.
And part of what you're saying is they are giving up access to their own GPUs to OpenAI. Is that accurate to say?
Yeah.
So yeah, I mean, I think it was a good decision, and
I agree, definitely a good decision.
I can't imagine they would be as critical to where we are in the AI era right now had they not made that decision. They have early access to all of the technology that OpenAI is creating. They got GPT-4 into Bing before it was in public, in front of customers, in front of OpenAI's customers, and it seems to be continuing with what they are trying to do with Office and Windows, the Office suite. So I think just that early access to OpenAI products seems worth the investment.
I think the sort of meta question you're asking that I think is really interesting is like, is big tech going to win the AI race or whatever, right? We always used to talk about FANG, right? Like Facebook, Amazon, Apple used to be Netflix and Google, right? You could replace the N in FANG with NVIDIA and it would be perfect. So FANG. Okay. And like,
goodbye streaming, hello chips.
Yeah. Goodbye streaming, hello chips, right? And I love Netflix, so they never got over like a couple $100 billion, which is where you said, NVIDIA is $1 trillion now. So pathetic $200-300 billion company. Is FANG gonna win AI? Like, I think that's a really interesting question, and I think like I'm kind of leaning yes. I guess to your point, like it seems like Microsoft's been able to grab OpenAI, which is per our last podcast still the most valuable asset in the entire industry, right? It seems like Amazon's getting very cozy with Anthropic in case that's actually the other big asset in the foundation model category. Facebook is absolutely like ripping on open source models, Llama. They're going to put like LLMs inside their ad products so you can have automated ads on Facebook and Instagram and all that stuff. They're also putting LLMs into consumer chat, products, right? Right. You can chat with celebrities, and I'm sure they're doing a lot with image generation. Yeah, exactly. And then Google seems to be like fully ripping on just like dumping large language models into every single Google product, like Google, Google Docs,
Google ripping
Photos.
I don't know if that is the conventional wisdom in Silicon Valley.
Okay, Google ripping for Google, for the record. You have to like grade them on the Google curve,
which you think they're an incompetent company coming out with new ideas.
Given that Google has not come out with a new idea in 15 years, they are doing a tremendous job putting AI products into their existing products, right? And so, for them, the number of launches this year has been tremendous, right? Graded on the Google curve, right? And then Apple has basically done nothing, but Apple always does things like 2 years late, and then hopefully they get it right. So I think
the great dream of Apple, as I understand it, is just that, we get to a point where a lot of these small models can be run locally,
local on
and
your phone,
that they have these great M1, M2, whatever generation we're on now, chips, and that even though they're not they're sort of combined chips, right? So there is some graphical component, right? And so that those chips would be sort of pretty capable at handling sort of small local models.
Totally. And I mean, Apple's argument would be we're using transformer-based models in photo recognition stuff, we're using it in speech recognition stuff, we're using it in autocorrect. They just put it in the iPhone, right? They're their take is always like, well, we will do it when there's a real customer need and this tool can really provide value. So I think like jury's still out there. I also think with Apple Vision Pro, it'll be really interesting to see what kind of generative AI and also just the AI driven tool set that launches with Apple Vision Pro. So I think like it's a really interesting question as to whether or not like this whole AI revolution is just going to entrench the power of the big five tech companies, because I think like they look pretty good right now.
You didn't mention Amazon, right?
I said Amazon was like cozying up to Anthropic, and also, I mean, you can elaborate on the other stuff they're doing, which is quite copious.
On Alexa specifically?
Well, and also AWS, right? Bedrock and everything, right? Yeah.
Right.
Well, it feels like Amazon, I mean, Microsoft is clearly ahead. Like with Azure and AWS, for those two companies, I think are the most important. I get you guys really care about Alexa and stuff could happen, but for the businesses today, like Amazon Web Services is so essential.
Much bigger.
And like Microsoft can go to people and say like Azure has a direct relationship with OpenAI, whereas Amazon, it feels like they've been pretty slow on this. But like you said, they have Bedrock and they're trying to come up with these sort of partnerships. But
yeah, well, their strategy is they're going to put everyone else's model on AWS, right? So they're going to be the middleman. Like they're going to sell you access to other people's models. So to Anthropic's models, and I think to the Llama models, and to whoever other models they can get on there, they're going to get everything on there. And the only like maybe they will, maybe they won't end up with OpenAI's models on there. I think that's an interesting ongoing business discussion. But like in the end, they're going to try to be, the supermarket for models in the cloud, right? As they have been in the last generation of all the different web tools they sell. So like,
but maybe Azure is not allowing OpenAI to put their models on AWS, essentially, right?
Yeah. So is OpenAI so good that will cripple Amazon?
But it is interesting that I imagine most developers who are using GPT models are doing that directly through the OpenAI APIs.
Yeah, probably.
And
not
there
Azure.
is, there's this world now that was already trending this way of big companies wanting to have like a foot in Azure and AWS so that you can sort of get the best of both worlds. But that would seem to be good for Microsoft, given that they were not the first place player. So even saying, okay, this further creates this world where you want hybrid cloud or you want to dual app clouds is sort of good for Microsoft. I can't believe I'm talking cloud computing on the podcast. I feel like even as wonky as we're willing to go, it's funny to be in that realm. Okay, Facebook. I think Facebook is releasing Llama, which is sort of they're sort of the king public company in open source models. Their top AI person is Jan LeCun, who's sort of been at this forever and has had a lot of spicy and open takes. I mean, I guess the core question is just like, what do you make of Facebook, which is sort of a closed social network, being so pro, like, let's give foundation models away, make it easy, let's commoditize them, let's just like give away. What do you make of the Llama strategy? Like, what's the point of giving away foundation models and making that such a core piece of your approach?
It's a great question. I love it. I think it's good. Yeah, I think it's great. I think it's really probably primarily about developer relations and creating goodwill in the open source and the developer communities that for them is more important overall to the like longevity of their business than owning, or monetizing these APIs, these models through APIs, which would be just an entirely new business for them. So I don't know. That's my take. I don't know. Do you guys have a different perspective?
I think that there's basically two strategies here with like open and closed source software, right? One is like closed source where you keep it private. You're like, we have the best stuff and people will have to come to us even though they won't know sort of how the internal workings of the software are because it's the best, right? And that's pretty much the OpenAI strategy, right? Like, and some of the other foundation model companies like Anthropic, whatever. And then Facebook is like, okay, somebody already took the closed source, we're the best strategy. We're going to take the opposite strategy, which is we're going to open source all these models, right? And we're going to hopefully build developer communities around these models so that people can make them better. They can, fine tune them. They can help optimize them over time. And then we will have the thousands or, tens of thousands of developers who are working on top of these models, build and improve them and build a network of plugins and optimize them and all this good stuff. And so we're going to get value out of the developer community, and therefore the models that our business Facebook is built on top of will get better and better that way, right? And so I think it's it may not work, but I think it's better than just trying to be the third best foundation.
It's differentiated.
Yeah, it's differentiated, right? Yeah,
and there are lots of great startups that have been built, where it's we're going to give away a foundation. We're going to give away, an open source project, and then you could build a business around it if it's super successful.
Yeah.
Also for Facebook, they probably benefit a lot from hiring great AI talent in the long run, and if that alone just gets them, marginally, a percentage.
I know
more
Reels is getting
AI
better. I feel like the algorithm.
Reels is good. Reels is a good algorithm.
When Facebook and Google nail AI generated advertisements, right, or just even the words in the advertisements, the copy, right, that, you have to imagine that's a huge tailwind for the business, right? Personalized ads that are created by AI in real time as you scroll the Instagram feed or the Facebook feed or whatever, you have to imagine that's you have to imagine that's a crazy good business for them, right? Or improvement to their business.
And lowers the friction to actually buying the ads.
It's kind of interesting if you think of it that way, because what you're saying, Max, is AI just improving and getting better faster is what's best for Facebook overall. Almost like if we had a breakthrough in energy production of energy or clean energy or something, that would be great for Facebook too, probably, because they would could run their data centers a lot cheaper and all these things, right? So it's almost just better for them to encourage the advancement of this industry faster, because a lot of the gains will accrue to them.
Mm-hmm.
We jumped into this with business strategy, which I am enjoying. But to me, what's interesting about Facebook's positioning is that, Google, Microsoft with OpenAI, to some degree, they're playing the responsible steward, right? We are going to make sure our language model behaves appropriately, doesn't get off the rails. Our brands are at stake, and we need to really guard them. Mustafa Suleyman at Inflection, who's going to be speaking at the conference, has sort of staked out, and we're going to interrogate this more, and so I don't want to caricature it before he speaks, but a somewhat open source skeptical position, right? It undermines the idea that we need to really be thoughtful and protective about who gets access to what and what these systems can do. And so Facebook is playing sort of a, flamethrower, fire thrower type role here, where they're throwing fuel to the fire on open source in an area where a lot of the other big tech companies would say, the thing we can do is do this really well and then keep it really closed off, so that, we have we're almost functioning as a state ourselves, where we're really being thoughtful. What do you take of Facebook, the big company, playing this role of democratizing?
I do worry, I guess, for them if someone uses Llama for nefarious purposes. Essentially, it hasn't happened yet.
It's a brand problem.
Yeah, I think that could happen. I think that this could be a long-running issue now for them going forward the next few years. If as we've talked about in previous episodes, these models can be used for nefarious purposes.
You're really laying the groundwork for reporters here. You're okay, people should be held accountable for what their foundation models, not
their
even their language,
models.
Their open source project does. I don't know
if I agree. I don't know if I personally agree that. I'm saying
you think that will be the
that could be a narrative for sure, and it just depends on how much harm can be done with open source models, and I think we don't know yet.
I mean, Facebook's look, our brand for trust and safety is already so bad that there's nothing we can do that could possibly make it worse. So why don't we just go for it on the business front? They're Cambridge Analytica, wait till they see what people will do with this model.
Well, Cambridge Analytica is a great similar analogy because they thought they were, at the time, they were opening up the Thorngren graph, and they were, giving data to, other developers and companies, and that was, encouraged almost at the time, right, by developers, and it blew back on them entirely, and it wasn't even good for their business to be doing that, to be leaking that data. So there is kind of a similar thing occurring here potentially.
Facebook's willing to be wild.
Well, the narrative kind of can change on you, right? That at the beginning of social networking and technology, this was encouraged that we would want, more data sharing or something with developers, and then fast forward 5-10 years, and it's not.
Have we all staked out points of view? I think we're all on the same page on, do we believe in open source? Like Databricks, super pro open source. Like a lot of the, obviously Hugging Face, Clem at CV1, super pro open source. Like I feel like generally we've heard from a lot of pro open source people. Do either of you have reservations? Or are you fully in the camp of like, it's an arms race and just like get the best stuff out and let good people sort of take advantage of it?
My take is that open source right now is great for the community, for developers. It's awesome to be able to, edit weights or use smaller models, run your own inference, all these things, fine tune, right? And that just might not be the case going forward. I don't know. At some point, maybe I will change my mind and be like, no, the models are too powerful. Like I don't want these open source models in the hands of nefarious actors or, China or something. So I guess my take is it's great right now, but I don't know.
But it's hard to pull, that's sort of once they have the models and it's gone too far, it seems hard to unwind the clock or whatever.
Yeah, I guess
that's fair.
I just believe the nefarious actors in this scenario are unstoppable. And as we discussed in the AI Kills Us All episode, that somebody's going to figure out how to, some bad actor is going to get control of a really powerful model, regardless of whether or not it was open source or not. So, yeah, I mean,
so you're very
I'm pro open source. Give the fruits of the labor away to the community. I mean, come on.
Why do open source?
Why do we think OpenAI changed its tune so dramatically on this question?
It's awesome business strategy.
Just
pure business is good for the front runner, right?
Exactly.
Like regulate it. Like make sure you have to spend a lot of money like following rules. Like that's good for big companies.
Because once they realized how good the stuff they were cooking was, why give it away? I mean, open source is the strategy when you're not the leader. Like you never give away the high quality stuff. Yeah.
Or the strategy that makes sense for Meta because they have these huge other businesses, right? Like it doesn't really make sense to give away models as a startup, I guess. I mean, maybe that's what Stability is kind of doing, or Midjourney, but you said they're kind of like becoming more closed source.
Imagine a world where like these algorithms are near AGI, like, and then they are locked down. That's the ultimate elite. So like a small group of companies gets to control like this sort of infinity resource. Like that seems insane. You know what I mean? I feel like that would become sort of one of the great freedom questions of our time, that just in any way restricting the set of people who have limited to access to like a godlike reasoning and information system.
I feel like we're backtracking on the AI Kills Us All episode.
Yeah. But I did think open source was key to Facebook, and that's how we got down this path. But reasonable that we've gone far from that. Though you've been the one that makes the point that like often these discussions undercount the AGI potential and how disruptive that would be to any of the other arguments that we're having.
I totally agree, and that's where I would question your assumption that everyone should have AGI, like without knowing how dangerous that could be for the world. That seems like pretty presumptuous to just assume that it should not be regulated by a handful of companies.
Yeah. I mean, it's a live experiment.
Give away the godlike power to the community.
Everyone deserves godlike powers. I mean,
everyone deserves godlike powers. Yeah.
I mean, they presumably they will have some counter countervailing
Yeah,
forces.
presumably, sure. Yeah, I guess if that's the case, but
Oh, I guess here's an easy way to make sure we haven't missed anybody. Let's do a collective ranking of who we think benefits the most from AI in terms of market cap movements experienced and to be experienced.
this is not a draft.
I'm putting in. No, we're doing it together. I think Nvidia should be our number one.
I mean,
you think
Microsoft
NVIDIA
would be the close one there, I think. I mean,
Microsoft stock isn't actually up
Yeah.
anywhere nearly
so
as much.
so Nvidia then probably. I mean, to your point, I guess. But I guess the question
What about
is, if
what
you
about
think,
Google? I would put Google pretty high here. It just
Microsoft
depends
is
on what
up
time frame.
34% over the year and 187% over 5 years. Google, you're putting Google?
I don't know what
like,
time.
to me,
what time
Google's
frame are
in
we
the
talking?
like tech becoming more important, and Google being all over it is good for tech, is good for Google. But like Google's relative dominance, which was so powerful in search, feels threatened by this. So
I think that's worth talking about because I just feel pretty confident that whole search impact of AI is very, very early, and Google will have plenty of time to potentially continue dominance with using LLMs and AI and multimodal models in their search products. So they have the front page, right, that everyone goes to for search, and they have really powerful AI internally.
right.
It just hasn't played out yet, but I believe that they will get there.
All right. So
I mean,
you want Google first?
It just depends what we're talking about. Like, are we talking about which of the biggest companies will have the highest market caps from AI? I mean, or just like relatively, like, is their position improved by AI?
How much the percentage their position is improved by AI?
That's what you're asking?
Yeah.
I mean, Nvidia.
Yeah, NVIDIA for sure. Microsoft second.
Agree.
Facebook third, I would go. I don't know.
What?
Yeah,
I don't agree. No.
Because algorithms are core to what they do and they're a discovery mechanism?
I think
or
if you
because of
actually,
Llama?
because of algorithms are core to what they do.
Okay.
I just think if you believe there can be a 50% improvement in advertising at scale through AI generation, then Facebook benefits more from that than anyone except Google, and they might
I think
benefit more than Google.
I have to put Google before Facebook.
Okay, I mean that's fine.
I would put
whatever.
Google,
It's a
but
tough
I would
call.
agree with Eric. But to
It's
Max's
really just
point,
about
it's-
search versus the Instagram feed. Which one gets more benefits out of AI? Like, I think that's the real question here. Like, or search versus the Instagram feed plus the Facebook feed, right? And I guess
Google
I like,
also has YouTube, which is competing in like shorts.
yeah, but it's gonna take a while to do video generation. I guess I don't know. Like, it's sort of about the ladder of how quickly generated personalized ads kind of get scaled up. So it's
Facebook, you're mostly talking about their ad products and ranking algorithms, but there's also an argument around on the content generation piece itself that, as we've talked about before, there's ability to create more compelling content and social media posts. And
I really think the only way you could make the case for Google is that you would say the ads on Google are going to get much better, right? I mean, like,
well, what about search itself?
you think search is going to get so much better
I think
that people are
search
going to use
itself
it more?
is going to get just so dramatically better. Yes, like I think.
I don't know.
I mean, time spent in search, you would think would
That-
go up if they're chat type products.
Well, there is
Time
an
to
argument
anyway.
that time spent goes down, right? Because you're just getting your answer faster, and
But it's
Yeah.
it's no longer a link. It's like less of a link
Right.
system and more like in the search, which is where Google ads are.
Yeah.
well, it just depends if it becomes more like a ChatGPT model where you're chatting with Bard or instead of searching. I guess that's where I'm coming from. I see myself doing that like almost more than I search Google today in the future, and I think they're the best positioned to be that like true assistant that I use every day to talk to, and instead of searching by typing into a
I mean, I was
box.
down on Google before, but like Google versus Facebook, I'm getting heated up just in the sense that like if you think of every product that Google offers, like if Gmail was amazing from AI and like the prompts were great and there was writing, like could become an even more insane product. Obviously, like Google Cloud Services. Wait, sorry, it's Google
Cloud
GCP,
Platform.
Google
Yeah.
Cloud Platform is key if they can improve there. Like search, YouTube, like there's just so many pieces of their business where they have audience and they could put this to work.
The only question we all have probably is execution on
Right.
all of these areas, but the
Right.
opportunity to me seems massive.
I mean, I guess I'm just going based on the fact that Google makes no money on anything except search, and the other stuff is great, but it's really just a data vacuum for search ads. Like,
Yeah.
they really don't make any money. I mean, they make money on YouTube now, so that would be the other big thing. But like, search ads is the whole ball game if you're just purely talking about the business of Google, pretty much. And so you have to believe that search ads are going to get way better, and or that people are going to spend way more time in search, which again is an execution question about like Bard versus all the other, large language models and chat models. So like, I buy the case. I just don't think it's as clear cut as you guys do, because I just think Facebook, like Instagram ads and Facebook ads getting better, would like just immediately dump right into the business. Which
And
would
what
be
you're
huge.
saying is that there's more of an obvious trajectory for the Instagram ads and feed to get better from AI than there is for search ads to get better from AI. Yeah.
Yeah, I mean, it's close. They're, they both are going to get a lot better. So,
Yep.
But it's about which one's bigger and what's the bigger impact, I guess. Yeah.
So now,
notably, like, so yeah, we it's Facebook or I don't know. Facebook wouldn't necessarily be my next
Sure.
either.
Oh,
but,
really? Interesting.
I'm willing to. I mean, I just feel
I would
like,
put it fourth at least, but what's next?
But Apple and Amazon,
Yeah.
like are now towards the bottom of our at least tech list. Obviously, tech being better in some ways lifts all boats. But I don't know. What do you make of those two and like what it means for them?
I would put Amazon next. I think they have an obvious role to play with AWS, and they have made a lot of great partnerships there with Anthropic already. They are probably working internally on models themselves. They are the number one cloud platform. They will benefit in their other core businesses through AI, potentially, Amazon.com and ads there, which is a increasing part of their business. And not to ignore,
You're allowed to talk about it.
Yeah, Alexa, which is critical to our business. They have an endpoint in 30% of US homes that is an AI assistant. It historically hasn't been amazing at talking to you beyond, controlling smart home features and telling you the weather and playing volley games. But it's completely possible that they will be able to add LLMs and AI experiences, as they've already demoed, that would transform that device in a way that would be, essential, would be a game changer for the Alexa business. So I think they're the furthest ahead in that area on like potentially integrating AI with, your average day through a voice assistant.
And Apple, the argument, Apple gets away with everything in that we can put them in like basically last place, and it's still like, well, they move slowly and maybe they'll figure something out, and like, I don't know. It's not really their wheelhouse. It's like, it's a lot of data. It's not about privacy. It's sort of not a device. If we really want to criticize Apple, we saw this report that, maybe Sam Altman and Johnny Ive and Masayoshi's son of SoftBank are getting the team together. The weirdest team headline you can imagine, to build a phone or some device that's sort of got AI at its core. That's a threat. I could buy a next generation sort of AI first device.
I just think Apple's moat has always been how unbelievably difficult it is to build hardware at scale, right? Especially like high margin hardware. There's almost no other large hardware businesses in the industry. And even if Johnny is on board and Masa is on board, you still need like...
Masa's got a great history.
You still need about 3 to 5 years and $30 to $5 billion to build even like a small scale, high quality hardware device. And just like, I think that's just a long way away. And anywhere where, Johnny and Sam are playing, like Tim Cook will pay some attention to that and make sure that they're not completely caught off guard, right? They all talk to the same people manufacturing the stuff in China. So,
but would you agree though that like Apple, while they're not threatened that much, like relatively, they are probably lowly ranked here.
Yeah,
in how
I think they're the most protected on the downside in some cases you could argue, and then also they don't have huge upside.
Yeah, if this is all bullshit, they're fine, and if it's good, it doesn't feel like they're getting disrupted.
Yeah.
Right.
I would like to throw another company in the mix here. What do you guys think about Tesla?
Yes, self-driving.
The old self-driving.
And the general XAI suite now, it's like he's somehow allowed to like merge AI research, like it seems like across all his companies.
True. I mean, I just think that I'd be much longer Waymo and Cruise than Tesla or whatever. I mean, like I just think that Tesla's fundamentally built around a hardware business model where you sell cars, and like if you believe we're entering a world where every car is self-driving and it can take you anywhere, like why wouldn't you be long like Uber or Lyft or Waymo or Cruise or somebody who's built around this model of like providing cars as a service rather than cars as like a jewelry object that sits in your garage 99% of the time. Like I just don't like, I think Tesla's a great product, but is it an AI first, self-driving first product? I always thought the idea that it was going to turn into a self-driving taxi fleet was like pretty absurd, but
I think that's a good point. I think Elon, his hype or marketing spin on this is that the AI that they've built to successfully get self-driving working at Tesla is so valuable in future endeavors, right? Like robotics.
But didn't they literally admit they gave up on all the AI they've been building for like until a year or two ago? They had been using the last generation of deep learning tools or whatever, and then 2 years ago there was recently there was a story that came out that basically said, we had to redo the whole thing once we realized transformer models, large language models are better, right? So they've been saying that for like 7 years, that like we're way ahead of everyone on building these self-driving models. We have gajillion trillion miles of data, blah, 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 which is fine, it's true. But like they had to throw it all in the trash can like 18 months ago. So like I don't find that like a super compelling like case that they have some moat around that sort of stuff. But who knows? I mean, they don't
have a lot of trust with like regulators. Like I feel like, Waymo and Cruise have just tried to be as responsible as possible. I mean, Waymo has been very conservative in deployment, and Cruise is like General Motors, like a company that I feel like every American politician is rooting for, right? I mean, Tesla, it seems like now has been able to position itself as very close to the Republican Party, but it feels like the administrative state and Democrats are going to be like extremely skeptical of them just throwing cars on the road. I mean, that's sort of cynical even about I guess the politicians I like, but I think I agree with Max's point of technology. I also think having a reputation for being a responsible, sane actor is important when you're doing something as dangerous as deploying the first self-driving cars.
I think it's a fair assessment.
I mean, we'll see. If they pivot the entire
they're
company,
getting a stock premium for it. I'm sure. Like,
if they
tried to, you can't. I don't know how you can ever measure this because it's like, well, the stock can stay inflated for like forever. Yeah. So if
they pivot the entire company to robo-taxis and they start selling $5 Tesla rides all around America, I will totally change my tune on this. But you pretty much have to embrace a disruptive business model in the next 3 to 5 years, which has historically been very, very difficult for any type of company. Because you're kind of saying all this money we're making today, that's going to be zero in 5 years, and we're just going to have to jump on the new thing and ride it out, which is really tough.
To be clear, I don't think the self-driving deployment cycle will be anywhere near as fast as that would suggest. So I don't think it's going to destroy their like existing car business. But I agree with the idea
10 years.
that
10 years.
It's hard. The classic startup situation, which you're articulating, is that like people don't disrupt their own good businesses, and so Tesla's in sort of the worst situation for that.
Well, just a counterpoint to that, do we believe that other companies are going to be able to sell fully self-driving vehicles anytime soon? It doesn't seem like it, at least.
Besides the 3 we've talked about?
No, I mean, those other companies seem to be only focused on the robo-taxi market as opposed to getting consumer vehicles that can fully self-drive themselves into the world. Like if Tesla is the only game in town there, and I'm not sure if that's the case, but right now it seems to be the only one that is going in that direction. That could end up being a very, very compelling offering if the only car you can buy that will drive itself anywhere is a Tesla.
Big if.
We'll see.
I feel like Waymo and Cruise are going to deploy city by city, geofence where they know they can do it with no deaths,
Yeah.
Anyway. Are there any other, I mean, this is great. I'm glad you brought up Tesla. Like, any more edge case companies we haven't considered? I mean, this is part of the problem, I think, right now, and why I think a Databricks IPO and the Mosaic deal will be welcomed. It's like there's a public market desperation for a way to bet on AI, which is why I think NVIDIA has done so well, because, these big tech companies are already very highly valued. The startups are private. Cool. Great. Thanks for coming on. And now we're going to Chris Miller with Chip War, who's a real genuine expert in the wonky world of chips. And so we go deep in NVIDIA, sort of their history, and, the big geopolitical question around the race with China. So give it a listen. Chris Miller, author of Chip War, thank you for coming on the show.
Thank you for having me.
I feel like so much of what sort of the regular person, or even, I don't know, the average startup founder, venture capitalist in Silicon Valley thinks of this artificial intelligence phenomenon starts and sometimes ends with ChatGPT-3. And it's very much the, like, what bots can we play around with? Like, how am I talking to some sort of AI? But in the background, doing reporting on some of these conversations, NVIDIA and like H100s and like weird chips come up over and over again, and sort of people's ability to get access to those chips. So I really wanted to have you on just to sort of like interrogate that and understand sort of the technology behind it. Can we just start off, like, when does NVIDIA start to matter as a company? Or just give us like the brief history of this company, because it was like a weird sort of gaming chip making company, right, for a long time.
Yeah, that's right. NVIDIA was founded over 3 decades ago, but its earliest couple of years was all in graphics. And graphics was most important for games, computer games, video games, which, think back 2 decades, they had the most complex graphic demands, figures moving across the scene, pictures changing very rapidly. And there were special types of chips that were produced by companies like NVIDIA for processing graphics. And if you think back, not so long ago, people would buy specific computers to have the best graphics capability. Now we sort of take it for granted, but for a long time, that was a real differentiating factor.
Can you explain sort of the difference between a GPU, a graphics processing unit, and a CPU?
So a CPU, which is the workhorse of traditional computing and computers and data centers, they're very good at doing many different types of things, but they do every computation serially, one after the other. And for most use cases, that's what you want, because you're undertaking different types of calculations. But for training AI systems, you want to undertake the same type of calculation repeatedly. And so parallel processing, which is what a GPU does, is capable of doing multiple things in parallel at once, which is why they're vastly faster for this type of calculation than a CPU is.
But why do AI tasks need to be parallel while like a normal computer task is sequenced?
Well, they don't have to be. It's just really inefficient.
It's much, right.
I think the key trend, there's been great research looking at the amount of data on which cutting edge AI systems are trained. And what you find, if you look at this for the last 10 years or so and chart it, the amount of data used in cutting edge systems is doubling every 6 to 9 months. So there's extraordinary demands for putting as much data as possible into training. And in order to make sense of all this data, to train your model to learn from the data, it has to undertake lots of calculations. And so the computing demands of training have shot upwards, not just exponentially, but exponentially at a rate that's faster than Moore's law. And that's why having the right chip for training has become very important.
Did NVIDIA see this coming? Like, their stock is up year to date. I think it's some like 200%. I feel like Jensen Huang, the CEO, you hear about him all the time. Like, was this a happy accident? It's like we're making great video games, and all of a sudden people want to buy our chips for the hottest thing in the world, or did they have some foresight here? How much was this a plan on the part of NVIDIA?
It certainly was a bit of an accident, and if you talk to the company, they'll readily admit that when they founded NVIDIA, they had no idea that AI would be an application. But over a decade ago, they began to realize that there were a bunch of PhD students and researchers at places like Stanford and Berkeley who were using their chips for things other than gaming, for complex calculations. And NVIDIA realized that if they tried to build out chips around this application, and no less importantly, build out a software ecosystem around it, that they could provide the chips that AI would require. And so they've been investing very heavily for now over a decade. And for a long time, that investment seemed actually quite foolish because most of their money
Right.
was still in graphics and in gaming. It's only quite recently that a data center and AI has become their primary
Right.
growth
Well,
driver.
people talk about artificial intelligence as a way to boost their stock price or to, seem like a more futuristic company than you are. For NVIDIA, it's like, okay, you're a gaming company guy, like chill out. And now, it's been totally validated that sort of all this talk of artificial intelligence wasn't total wild hypemanship or whatever.
Well, in between there, they were also a Bitcoin mining
Yeah, I
company.
know. Yeah, exactly. They did have the crypto. They're definitely good at seizing the moment. But they were being used for crypto mining, right? Is that what it was?
That's right. Yep.
And like, yeah, how do you see Jensen, the CEO? Like he's one of the co-founders, right? Or what's sort of his role at the founding, and how do you see him as sort of a CEO today?
He was one of the three co-founders of NVIDIA. They met in a Denny's in San Jose to devise the business plan in the 1990s. And Jensen, I think, deserves a lot of credit for realizing a decade ago that AI could be a real growth driver. At the time, people thought it was a really irresponsible thing to do, plow all this money into building a software ecosystem around chips. No one else did that. Most chip companies just made chips. And if you go back to the debate in 2015, around that time period, you can find lots of equity analysts saying, what's this company doing, spending all this money on software rather than selling chips? It's a waste of money. And worse, they were giving the software away for free. But it turned out to be a brilliant move because everyone started using the CUDA ecosystem, which is the software layer on top of NVIDIA chips. And that's put it at the center of the AI world.
A key piece of the chip world is this sort of like, are you designing chips? Are you the fab? Can you just sort of explain that and where NVIDIA sort of fits in? Like, are they actually, we say build the chips, but are they like building the chips?
Yeah, that's a key distinction. They're not actually building the chips. They only do chip design. From day one, they were what's called a fabless chip company. They didn't have a fab. They only did the design. And chip design is, in many ways, like a software design type of business. You basically write the code of the design and then you email it off to the factory or a fab in semiconductor parlance, and the fab actually does the manufacturing. And so in the case of NVIDIA, their most important manufacturing partner has been TSMC, the Taiwan Semiconductor Manufacturing Company, which manufactures most of their chips. And so today, for all of NVIDIA's key AI training chips, they're all manufactured by one company in Taiwan.
And do they make basically all NVIDIA chips, or?
They currently make all of the key AI chips that NVIDIA produces, and they've been the most important producer of NVIDIA chips from day one.
And is NVIDIA, like, how far ahead is NVIDIA right now in this sort of AI chip? Are they singular? Like, yeah, where are they today?
Well, in terms of market share, NVIDIA is far, far ahead. So it's estimated that up to 90% of cutting edge AI systems are trained on NVIDIA chips. You can debate what's the definition of cutting edge, but NVIDIA's market position is extraordinary right now, and that's reflected in their stock price. I think if you ask, are they technologically ahead of competitors, whether AMD, which is another chip maker, or Google, which has a chip called the TPU, which is also used for AI training, that's a harder question to answer.
TensorFlow, right?
Exactly. Yeah, exactly. Exactly. And that's a hard question to answer because there's both, technical specifications you could look at, but there's also ease of use. And so if you've built a system, trained it on NVIDIA, if you yourself as a engineer have gotten comfortable with NVIDIA's products and with CUDA, there's also a switching cost of moving to somebody else. And so NVIDIA's both got their own capabilities, but they've also got the first mover advantage. Everyone's used to their products.
But they're really scarce right now, right? I mean, my sense talking to startups and investors, I mean, you hear NVIDIA is like in every venture round now because as part of the funding, they can sort of promise people their chips, which then they make money back from the startups. It's like a great world. They're playing kingmaker. Like, what's your sense of how scarce their artificial intelligence chips are?
Well, right now they're scarce. I hear the same anecdotes that you're hearing, and NVIDIA and TSMC, the manufacturer partner, have both said it's going to be a year or so until supply normalizes. And the problem is actually not that TSMC can't produce enough chips, but they can't package them because they use a very complex new packaging technology to put the chips right next to the specialized memory.
I assume you don't mean in a box. Yeah, you're like, you place the chip on something. Right, yeah.
That's right, yeah. So traditionally chips were packaged
That would be funny, though, if it's like, oh, the Apple-style box is like holding them up at the end. Anyway, so go ahead.
Yeah, so packaging traditionally was a really boring part of the chip business. You take a chip, you'd put it in a plastic or a ceramic package, and that was done. But now it's increasingly important because you need to get your processor and your memory as close as possible with as fast an interconnect as possible. And so companies like NVIDIA are leaning more heavily on having the right packaging capabilities to provide the most advanced outcomes. And so it's actually TSMC's packaging capabilities that are the limiting factor right now for producing more NVIDIA GPUs.
And what is an H100? Or like, how different are these chips from the GPUs that everybody got excited about in the first place? Like, are they server chips? Or explain, what is an H100?
It's just the newest version of a GPU that NVIDIA offers specifically for AI training. And the reason people get excited about new versions of chips is because the rate of change is so fast that a new version is always not just incrementally better, but a lot better than the old version. It's not like the iPhone 15, which is a bit better than the iPhone 14, but we've stopped noticing.
I wanted to update, and I'm like, this is not enough necessarily to get me from 13 Pro or whatever. Yeah. The chips are different because of the Moore's law dynamic, which is says you roughly double your processing power every 2 years, and that's not a perfect metric, but ballpark that tells you just how rapidly the technology improves, and the H100 is the most advanced chip that NVIDIA offers. So Moore's law is still alive today.
So Moore's law is actually not a law; it's a prediction that was set out by Gordon Moore, who founded Intel. In 1965, he predicted that the number of transistors per chip would double every year or two, which means that the computing power of chips would double every year or two, and that's been holding.
And he
true
said it would be
all
a
the way up to the
decade,
present.
but then it's been true for a long time, right?
That's right. Yeah,
I'm just stealing from your book, of course, but it makes me sound smarter when you get to read the book in advance, so you know all the answers. Anyway, go ahead.
But that's right. So Gordon Moore thought it would last for a decade, and here we are, half a century later, and Moore's law is still basically holding up. The rate of change increases and decreases at certain times, but it's basically true that if you wait 2 years, a new chip will have twice as many transistors and therefore twice as much computing power.
I mean, this is sort of a hard question, so I don't know if there's an easy answer, but yeah, how much credit would you give then the improvement of GPUs for what's going on in artificial intelligence right now relative to, attention is all you need, or, the papers in terms of the approaches to actually use these chips to run the software?
Well, I think it's the case that there's multiple factors driving innovation, but the way I like to think about it is, what's improved most over the last decade? Is it the case that software engineers are 16 times smarter, or is it the case that algorithms are 16 times better, or is it the case that because of Moore's law, 2 to the 5th, we've got, a vast increase in the number of transistors. I think it's primarily computing power that's driving this.
That's what you want. The chips guy comes on and he says, it's the chips. A key theme, obviously in the book and sort of for anyone thinking about this situation is, the rivalry with China and sort of the delicacy of the global supply chains. There's the chip rivalry with China, but also in artificial intelligence, if we're worried that this is the potential sort of path to some sort of, generalized intelligence, there's also the real question of whether the U.S. gets there first. Yeah, so, there's so much to hit at. I guess the first question for me is the United States getting most of NVIDIA's chips? Or, like, how many of those chips are going to China? Is China getting access to those right now while they're scarce?
Well, the U.S. last year imposed new rules that said NVIDIA can't transfer its most advanced GPUs to China. And not just NVIDIA. Any company producing chips above a certain threshold can't transfer them to China. So H100s are illegal to transfer to China.
Wow,
so
okay.
China's not getting any of those.
Okay.
But NVIDIA has designed chips that go basically right up to the threshold called A800s. And Chinese firms are reportedly buying very large volumes of those. So China's getting a lot of GPUs, but they're less advanced than what a U.S. firm can buy.
What would their next best option be?
Well, their next best option is NVIDIA's second best chip.
Oh, man. Okay. Right. And China tried to build its own fab, right? A competitor of TSMC. What's the status of that, and how much, it's fun, especially in the US and given the market returns, like, to talk about NVIDIA, but, like, how much does this all hang on TSMC?
So China has been investing very heavily in its own chip industry. It's got both companies doing the design side and the manufacturing side. There are a number of Chinese GPU designers that seem to have pretty competitive products. Although even in China, Chinese firms prefer to buy NVIDIA's chips, so they're not as good, it seems. But the big challenge in China is the manufacturing side, because TSMC, the Taiwanese firm, has been around 5 years ahead of the leading Chinese firm, SMIC, for a very long time. For at least a decade, there's been a 5-year gap. So both companies regularly improve their manufacturing processes, but the rate of change in both is roughly the same. So TSMC is always half a decade ahead. And that holds true up to today.
And what about the United States? Like, hadn't Intel been trying to become a fab? Like, what's the state of our ability to actually manufacture these chips if, there's a war in Taiwan, God forbid?
Well, yeah, that's the dilemma. So Intel does make its own chips, but around 5 years ago, it faced some severe problems with its manufacturing operations. And so for its most cutting edge chips today, Intel now turns to TSMC for the manufacturing. Now, Intel right now is trying to reformulate its manufacturing processes, and it hopes that they're saying by 2025, they're going to be producing their most advanced chips back in-house again, and that those chips will be as capable as a TSMC-made chip. But right now, Intel's most advanced chips are actually manufactured by TSMC.
And then there's like the people who make the machines that that allow TSMC to do what they do. There's like one company of those, or what's that company?
Yeah, that's right. So TSMC, they know how to use the machines to make chips, but the machines themselves are produced by a handful of other companies, a couple in California, a couple in Japan, and then one in the Netherlands called ASML, which produces the most complex of these chip-making tools.
So is quantity everything here with the H100s? Like, Microsoft has this cloud computing offering, Google has its, Amazon obviously has Amazon Web Services. How much are those services trying to stockpile AI chips? And, then these startups, whether it's, Anthropic or OpenAI, how much is their game just like, we're going to win if we assemble the most H100s? Is quantity sort of the game right now in terms of getting access to these chips?
So long as there are shortages, I think quantity is a key part of the game. And what you see is that NVIDIA now realizes it's got a lot of influence over the future of the cloud computing market. And so NVIDIA has been I think, pretty actively trying to build up other cloud computing firms
Like
by giving them
CoreWeave and Lambda Labs, right?
exactly, giving them access to GPUs. And NVIDIA, I think, quite rationally wants a more fragmented cloud computing market because that's a market in which it has more market power relative to Microsoft, to Amazon, and to Google.
So we alluded to this, but sort of, can you walk me through the tech giants in terms of credible competitors to NVIDIA? I mean, I guess start with Google. It sounds like maybe they're in the lead. I want to know about Intel, and then is there anybody else who's relevant or even close?
Yeah, so Google has a in-house designed chip. They've got a big design team that has designed a chip called a TPU, which stands for Tensor Processing Unit, but fairly similar to a GPU that is used for AI applications. Google has a vast cloud computing business as well as its own vast data center. So lots of experience running very complex computing operations. But empirically, we know that companies prefer to use NVIDIA chips. At least they do right now. That could change as Google's chips get better, as scarcity drives up the price of GPUs, but that hasn't been the trend. The preference has been for NVIDIA. Then AMD is the other company that is a competitor in producing GPUs. It's a chip design firm. They also manufacture with TSMC in Taiwan.
Are they American?
They're an American firm, that's right,
Okay, yeah.
based in Texas. And they manufacture fairly competitive GPUs, but the key difference between their chips and NVIDIA's is that NVIDIA has the ecosystem around it, the CUDA ecosystem. And so once you're bought into that ecosystem, right now, the switching costs are substantial enough where you just prefer to stick with NVIDIA if you can get access to enough chips.
Is Intel relevant at all?
Intel is trying hard to produce competitive chips. And I think over the next couple of years, we'll see it roll out a series of new products that are designed to compete. But right now, it's a small player.
In my understanding, like in cloud computing, like part of the beauty of like an AWS is that you can sort of, it's flexible, it's elastic. We can sort of have some people do the computing, then you sell it to another customer at a different time. Why hasn't that been the case with this artificial intelligence computing? I mean, I hear people talk about it like you're running full bore, like these data centers are super hot. Like what's so different about AI processing?
I think the key difference is that the demand for compute power in AI training is so large that there's just a deficit of it. There's just a deficit. And so the systems that firms like OpenAI are trying to train are so vast that they can't share their infrastructure because they need all of their infrastructure and they need even more of it than they actually can get access to. And so the cloud computing business has been a business, as you say, about engineering more efficient systems via sharing. But in AI training, no one wants to share because everyone needs more compute than they can actually get access to.
Right. And then there is also this sort of perceived almost like zero sum, like you want to deny your competitor access. One company we haven't talked about, that we talk about in the laptop world for chips is Apple. Like what's the status of Apple in this? Sometimes people talk about Apple and artificial intelligence on like local processing. Is that a possibility, or how do you see Apple as being relevant or not in this race?
Yeah, thus far we've been talking about AI training, and AI training happens almost exclusively in big data centers. But there's a big question about what inference will look like in the future. Some people think that inference will mostly happen in data centers, that you're going to ask a question of ChatGPT, you'll send it back to the internet to the data center, chips in the data center will think about it and give you an answer back. And that is efficient in some ways. You have all the compute, all the chips in one big data center. And so you can start to set up some of the sharing and efficiencies that we just discussed. But the downside is you have latency issues if you're sending all the data back and forth, and there's costs associated with moving data. And so an alternative paradigm is doing more of your inference on the edge of networks, in your phone, in your car for autonomous driving systems, in your PC. And that's where companies like Apple could start to play a much bigger role. Right now, I think the market for inference on the edge is still very much in flux. We're in the process of seeing many new types of chips rolled out precisely for that purpose.
So it just sort of depends on where. it's one of these like sort of personal computer versus server level questions back in the 90s, where it's like, okay, is computing going to continue to happen in the cloud, or is there some model where local computers are going to do it? And you're saying that if it is local, then maybe Apple's in a better position because they have these great chips for individual computers. Is that right?
Yeah, that's right. And there's, I think, a pretty straightforward cost equation of, if the cost of data transfer is high, you'll try to do as much as you processing can on the edge. If the cost of data transfer is low, and the benefits of having big centralized facilities are substantial in terms of the efficiencies you can reap, then you'll have a much more centralized inference process. And it might vary even between different use cases. In a car, for example, if you've got a pretty autonomous car, your willingness to depend on a data center to tell you to turn left or to turn right is going to be pretty limited. I would hypothesize. Right. Whereas for your phone, maybe
you want to make sure no
matter.
Matter what, you can get the answer. But if it's for Mid-Journey, I can wait till it boots
exactly.
up. I mean, we talked about NVIDIA earlier on in terms of, there was a brief period where they were essential to crypto mining, and one of the key storylines I think for the non-crypto world that was just watching it was all the energy consumption around those crypto mines. Is that true for AI? I haven't heard that same environmental story get picked up in this case, but are we destroying the environment in our pursuit of artificial intelligence?
Well, I think we haven't heard much about it just because there's such an extraordinary demand for computing that companies haven't gotten around to thinking about the consequences. But the short answer is yes, it's extraordinarily energy intensive, and we're going to get more efficient at it as time passes. But right now there are such demands for energy in data centers that there are some places in the U.S. where it's difficult to build a data center because there's no spare electricity capacity for the data center. It's already a gating factor.
Have you seen any estimates about energy use, or anybody trying?
Well, it's tricky because everything depends on how much more efficient you think things will get over time. So you've got to assume we're going to be a lot more efficient, making the same compute available at lower energy demand in 10 years' time. But
right.
At what curve, it's very difficult to say.
Yeah, and to be clear, I think what is the point of energy if not to sort of push the cutting edge of like computing? It seems like a very valuable use to me, but it'd be interesting. I mean, you obviously want to make sure companies aren't being sort of cavalier about it. And,
well, they're certainly not cavalier because if you look at the cost of running a data center,
don't
energy
waste
is
it. Yeah.
a critical cost.
Well, I mean, I don't know if you're OpenAI, you raised $10 billion. It's you can become sort of irresponsible. There isn't the same market pressure if these companies are able to raise what are basically like research grants to figure this all out. We sort of jumped into artificial intelligence, but the broad theme of the book, the idea that we often think of global infrastructure and the sort of weaknesses and vulnerabilities in terms of like oil, right? I mean, it's like, did we go to war in Iraq over oil? What is sort of the real what are the weaknesses with chips, and why do you think sort of this chips arms race is so important when we're thinking about sort of geopolitics?
Well, the reason I wrote Chip War was when I realized first that we're surrounded by thousands and thousands of chips over the course of our daily lives, not just our phones and our PCs, but it's cars and dishwashers and coffee makers too. Second, when I began to understand how critical they are for AI. And then third, when I realized how concentrated the production is in just a tiny number of countries and really just a handful of companies. Taiwan being the most surprising example of that. And so when you look at the U.S.-China race to develop more advanced AI systems and in tech in general, then realize that both China and the U.S. are dependent to a shocking degree on chips made in Taiwan to power their most advanced AI systems. It's an extraordinary situation that we've all found ourselves in, and it's a very dangerous one, given the concentration and given the dependency.
What would be the consequences of China having a chip edge broadly in artificial intelligence?
Well, just like we're preventing China from accessing our most advanced chips, I think one has to assume that any country with that position would do the same to us. And right now, Chinese firms that are trying to develop AI systems are doing so at a really severe disadvantage because they've got much less access to high quality hardware than does OpenAI or Google. And that's, I think, only going to accelerate into the future as countries, including the US, become more restrictive in terms of controlling access to different types of AI hardware. And so it's a good thing that we've got most of it designed here and most of it manufactured in friendly countries, because what we're going to see, what we're already seeing, what we will keep seeing, is more politicization, I think, of the hardware that makes AI possible.
Is the United States still seems great, I guess, at chip design, given we have so many of the leading firms. Do you think we could ever produce a fab, or like what makes TSMC so uniquely capable at building a fab? Like, we're talking culture, money, like what's driving that in your opinion?
Yeah, it's not, it can't be a cultural thing because Taiwan hasn't always been the center of the chip industry. If you go back 4 decades ago, it was Japan that was the world's biggest producer of advanced semiconductors. So it's primarily, I think, the result of TSMC's business model, which has let it scale, and the scale has let it drive efficiencies. And so when TSMC was founded in 1987, at that time, almost all companies both designed and manufactured chips in-house. They did both sides of the equation. And the founder of TSMC, Morris Chang, realized that as it was getting more complex to manufacture, companies would prefer to outsource it. And so he decided that he wanted to be sort of like Gutenberg was for books. Gutenberg didn't write any books, he only printed them. Morris Chang and TSMC, they didn't design any chips, they only manufactured them. And what that meant is that he could produce chips not just for one company, but for lots of companies, for AMD, for Apple, for Qualcomm, for NVIDIA. And so today TSMC is the world's largest chip maker. And precisely because it's the largest, it's also the most advanced because it can hone its processes over every single silicon wafer that it manufactures.
How can you make any predictions about how much you think AI chips are going to improve, or like what do you see sort of the next couple years looking like in terms of like, do availability problems resolve, and how much more do you think these chips will improve over the next couple years?
Yeah, on the availability front, NVIDIA and TSMC have said they expect it to be a year or so until the shortages get resolved, but I think they're going to get resolved. Prices are such that there's a very strong incentive to solve the availability problem and sell more GPUs.
Sometimes people think they want to keep a shortage to keep sort of demand high. You think they want to produce as many chips as they can get out there to make the money while it's there to be made, or?
Yeah, I think that's right, because they're it looks like they're a monopolistic producer. They've got 90% of the market, but if they can't supply chips, there are competitors. There is Google with TPUs, there is AMD. And so if there are long run shortages that are in the supply chain, people will turn to competitors. And so they've got a strong incentive to get supply increased. And actually, part of their strategy is, again, to put their chips at the center of the AI world and make it the gold standard. And the more people that design, the more people that train, more people that study using their system, using the CUDA ecosystem, the more likely NVIDIA is to be at the center going forward.
And then I guess sort of the next chip they have is hard to know, or have there been any leaks about what the future looks like in terms of these artificial intelligence chips?
I mean, I think the best guide is to look at the past. And what you find is that that for over the past half decade, they've released a series of better and better chips that, ballpark Moore's Law gives you a pretty good guide as to where things should be in a couple of years' time. Bigger, more powerful, hopefully somewhat more power efficient. And the other area of focus is the interconnect speed between semiconductors. So there's the GPUs themselves, there's all the networking equipment that moves data between chips. That's also an area of really intense focus right now. And I think we're going to see a lot of progress for the coming years.
Jensen, I mean, did you interact with him at all for this book, or?
No, I didn't actually. I interviewed his co-founder, but not him.
Interesting. Yeah, I mean, just like observe, like it must be crazy to go from sort of being seen as this, like, I don't know, wild sort of futurist to all of it seeming to come true, or the world sort of agreeing with your futurism? I mean, he sort of he wears like leather jackets and dresses all black, or like, what do you make of him? And yeah, how much has this been sort of a vindication for him?
Well, I think he sort of sees himself like Steve Jobs was for the iPhone moment, he is for the AI moment, and I think that's right. I think he has played that role because he deserves a lot of credit for investing in the types of products that have made AI possible at a time when most people thought it was either crazy or possible but only relevant for niche academic uses, or something that would never be financially viable. And look, he's built one of the world's largest tech companies around it, and already there are products being produced on a regular basis using chips that his company has pioneered.
I agree with you. You can make a fortune. Silicon Valley can love you, but I feel like the world will only love you if it's your device in their hands or it's your brand. You know, it just doesn't seem like they have a path for like consumer love, right? I mean, do you see them trying to take advantage of this and go, offer other products, or they're so good at chips, they're gonna they'll win the technologist's heart and be happy with their cash pile.
Yeah, they're so far from the computer in terms of where they sit in the tech stack that most consumers don't even know they exist.
Right. Or gamers do is sort of the funny thing, right? Yeah. How did you get into this? Like, what were you? Sorry, I don't know as much of your background. Yeah, before you wrote this book, were you a chip nerd or what?
No, not at all.
Oh,
Not
really?
at all.
Okay, what was your story to the book?
So I'm an economic historian by training, written a couple of books on different aspects of economic history, and decided to write the book when I came to realize how important chips were, and was shocked myself that I'd never paid any attention to this industry. And so it was the combination of learning that almost all advanced chips are made in Taiwan, which was shocking, learning that chips are so extraordinarily difficult to manufacture, and transistors in your iPhone, for example, are smaller than the size of a coronavirus, manufactured by the billions. That was an extraordinary fact that got me into it. And then finally looking at the ramifications for AI. I like most people, have thought about AI as a question of either software or of data. Data is the new oil, I'd read a million times, but it turns out that's not exactly right.
Did you go dump all your money into NVIDIA, or
I should have.
Did you see the stock market? I mean, I know. Well, if you're an economic historian, like, do you have a view on whether, okay, this is a great company, but it's overvalued? I mean, do you have any?
You shouldn't
view
turn
on
to me
that?
for stock market advice,
No,
but I mean, I think the key question about NVIDIA is will it? I think it's clear it will continue to play a dominant role in AI training. Maybe it'll lose market share, maybe it'll win market share with Google, but it'll play a central role. But in the inference market, will NVIDIA be as central there or not? That's, I think, the key question that we're going to find the answer to in the next couple of years.
And do you think China is close to catching up?
I think China is not that far behind, but China has been not that far behind for some time. And because the rate of advance is so rapid in terms of design in the US and manufacturing in Taiwan, it's very, very hard to catch up. And so long as companies like NVIDIA and TSMC keep racing forward, catching up is just going to be extraordinarily challenging for China, no matter how much money they pour into it.
And are Japan and South Korea relevant to this conversation?
Well, that's an interesting question. Japan is relevant because if you look inside of a chip making facility, there's a ton of Japanese machine tools, and there's also a wide variety of ultra specialized chemicals made in Japan. So a lot of the chemicals used in chip making, because of the precision required, have to be purified to the 99.99999% level. A lot of those are only made in Japan.
I wanted to go back, and I know this is like a complicated question, but like, what are the tasks that are being thrown at these chips, right? Or you talked about sort of matrix computing, or is there like one task over and over again that these chips are being asked to do, or it's a lot of different things, or how are the foundation models sort of translating to the chips as best you can explain it?
Well, I guess the way I would explain it is, if you're trying to train a chatbot like ChatGPT, you train it by taking all of the language data in a vast data set like Wikipedia. You essentially read Wikipedia and identify patterns. And so
And that's like inference that you've been talking.
that's training. That's training. So
okay.
training is identifying the patterns. So, what is the next word I'm going to say?
Right.
You know it's say. And ChatGPT knows that because it's identified thousands of other instances where sentences like that ended with the word say. And it did that because it read lots and lots of books and articles and Reddit posts online. And then when you go back and ask it a question, which is inference, it gives you a pretty good answer because it has a pretty good sense of what the most likely word is going to be.
So you're saying they're training the chips based on a lot of data, and then it makes an inference about what it thinks the sort of fill in the blank of the prompt, basically.
Yeah, inference is just an educated guess, a probabilistic guess. And what's cool about ChatGPT is that it's not just fill in one word,
Right.
it's fill in dozens of
Right,
words.
I know, it's insane. One thing I'm still trying to get my head around is, like DeepMind, right? Like when they trained, computer systems, I guess, to compete on chess or Go or Dota. Like my sense is that, they're using sort of this sort of scaled data approach, but they also have like specific ways they're teaching it to think about specific problems. Or like, are those types of approaches to AI also using these same chips, or are they still sort of invested in the same arms race?
Yeah, well, the chips just do the math for you, and so they'll do whatever math you ask them to do.
Yeah, exactly. And they're not. And then the interaction between like NVIDIA's like programming language is super interesting, because they're not like the foundation models are not being written in that language, right? But they're sort of bridging.
That's right. Yep.
And it's just about, it's fundamentally allows them to optimize what's happening on these chips much more than maybe they would on like an AMD chip, even if it were
And
as powerful.
it's easier, it's more familiar, and therefore there's a big moat around NVIDIA's position.
Yeah. So have you like become like, were you bullish on like AI before writing this book? Or I'm curious how much your view has really changed on, like, I don't know, like generalized intelligence or like the imminence of self-driving cars or any of that.
I think that actually I'm in the long run, I'm very bullish, but I think in the short run, the last 12 months, there's been a whole lot of excitement of the imminent arrival of AGI,
Right.
which I'm not so sure I see it happening in 2023. I think if you look at the trends are all very positive. AI systems are getting better, more capable. But I think there was, due to ChatGPT, a popular sense that we're going to get some extraordinary products in our hands right away. And actually, it's going to be a couple of years before we see AI, the current wave of AI products deployed in a big way that meaningfully impacts economy or society.
Yeah, I think we're all watching to see if this hype wave is about to end or not. I mean, there's a world where this is sort of peak NVIDIA, right? Like we have this sort of mania around AI, everybody's running towards it, and then it turns out, ChatGPT doesn't improve that much, and self-driving cars still have a lot of edge cases, and the chips don't solve everything, even if they do get better, like you're saying. Like, I don't know, how likely do you think that is, or do you have a sense of whether better years are ahead, or this is sort of a peak moment for the company?
Well, it's been a very good year for the company, so I wouldn't be surprised if it's at least a localized peak. But I think, for AI applications, most people think of what's the consumer application for AI. What's the iPhone of AI. But it seems to me that for the next couple of years, actually, most of the application and most of the money in AI will be in enterprises. There's enterprises that have vast data, they've got a desire to use it efficiently, to monetize it. And so that's where I think we're actually already seeing a lot of the investment, and a lot of the early products are happening in pretty boring places inside of enterprises. But that's probably okay. That's what's going to drive, I think, the building of effective products in the long run.
Enterprises, businesses, just translated for like the regular person. I used to work at Bloomberg. they've actually come out, I think, with their own foundation model to show how they can train financial data. Do you have a good example of where you think corporations will put this approach and data to use?
If you imagine a company like Walmart, they have to every day decide what price to put all of their products. And they decide pricing based on a whole variety of different factors, what their competitors are pricing, the availability of products, very complex process. And that seems like a perfect use case for trying to use more advanced AI algorithms to set better prices more rapidly.
Who gets,
boring,
is it
important.
Kmart, this blue light discounts? What's Walmart? I forget. But yeah, who gets the discount? Where? Right. A lot of products to keep track of. Have you, like, it feels so absurd to ask this, but like what the chip business looks like in a world of AGI, generalized intelligence, or like, have you gamed that out at all? I mean, there are people who think it could happen, 5 years from now or less. Like, do you have a view on it, first of all? And then second, what would it mean for the chip world?
Well, I guess my sense is that we're a long way away. I'm still waiting for ChatGPT to accurately complete all of my sentences. It's still at
Exactly.
a 90% rate, and the other 10% are pretty bad. I think it's going to require tremendous advances in semiconductors to make possible the tremendous increase in computing that more advanced AI systems will need. I mean, that's been the trend. The trend has been AI systems only advance when we apply more computing to them. And so if we want systems to be twice as good as they are today, we're going to need something not too far off from twice as much compute to make it possible.
Are there, there was this, I covered Rigetti and sort of the quantum computing world. Do you have much optimism there? Do you spend time on them in the book?
Not in the book. My sense in speaking to people in the quantum world, and then looking also at how in history new computing technologies have disseminated, is that actually even revolutionary technologies, they're implemented slowly. And so suppose we get to the next couple of years the first practical use case of quantum computing, it's going to be a years-long process of beginning to implement that in all sorts of different computing use cases. And so I think we shouldn't expect to have a quantum-powered iPhone anytime soon.
It's insane to think, like, on the one hand, we have public companies that people are sort of speculating and betting on that, produce quantum computers, but that really do nothing practical. You can go with, I swing back and forth. On the one hand, it's like, great. It's amazing that our system will invest in such bleeding edge technology and give it a chance. On the other hand, for the shareholders, like, everybody could decide to give up on the effort with like higher interest rates. It's a crazy function of the global economy.
Well, I think it's interesting that a lot of the companies that are investing the heaviest are also big cloud computing operators. And that's, I think, because they believe that quantum will be actually most useful in a context where it's closely interlinked with huge volumes of classical computing. And so actually we're going to need more advanced silicon chips to make quantum practically applicable.
And is there any sense whether quantum and the GPUs sync up or where they fit in that story?
There are many different paradigms for how you specifically sync classical and quantum computing, but right now nobody knows which of the many paradigms will win, if any of them.
To wrap it up, I mean, what do you think the regular person should take from all this? Like, it feels very far from their lives. Like, they maybe don't even know what NVIDIA is. Like, they tried ChatGPT, their kids using it for homework. It's not in their life yet. Like, Silicon Valley loves to get itself worked up about things that don't sometimes translate. Like, what do you think the lesson or the key thing for like the regular person right now is in terms of what's happening with these chips?
I think if you went back to 1965, which is when Gordon Moore first set out the phrase Moore's Law, and you asked what's the impact of Moore's Law on the average person, the answer in the short run was approximately nothing. But the answer in the long run is that it totally transformed society, economy, technology, everything, because we put computing and therefore semiconductors into basically every product that we rely on. And I think we should expect the same to be true for AI. What does it mean for me tomorrow? Probably not much. So what is it going to mean in 10 years and in 20 years when every aspect of human life is being impacted by it? Well, it'll be transformative in all sorts of ways, most of which we probably can't even imagine today.
For the startup entrepreneur, where do you think there's opportunity to build a business? Maybe you think they should go out and start the next NVIDIA, like it's a heavy lift, but like where do you think really, with the progress that we've made in these chips, that there's real business opportunities still?
Well, I think if you've got the idea of the next NVIDIA, you should absolutely go do it.
For America, if only that, yeah.
But I think you're right that, companies like NVIDIA, they create the infrastructure on which many different types of systems can be built. And if you go back to, the smartphone, for example, smartphones were themselves a platform on which you could build lots of different things. And I think we're still in the super early stages. We're basically in stage 0 in terms of figuring out what are the ways you can create products out of generative AI systems.
Right. Yeah.
Right now, there are hardly any companies that make money selling their AI systems.
And of course, the challenge for entrepreneurs is, people who built early iPhone apps and Facebook apps, they don't all pan out. Sometimes you come too early. You can be right that a technology is transformational and get the timing wrong. And I guess that's the sort of confluence of luck and insight in the business world. It's a tough one to predict. Chris, this was awesome. Thank you so much for coming on the show. It was great to talk to you.
Thanks for having me.
That's our episode on chips and big tech. Thanks for listening. I'm Eric Newcomer, your host, author of Newcomer. Thanks so much to Max Child and James Wilsterman, co-founders of Volley and my longtime friends. Shout out to Scott Brody, our producer, Riley Kinsella, my chief of staff, Gabby Caliendo at Volley, who's helping organize the conference and playing a big role behind the scenes. Thank you to Young Chomsky for the theme music. Please like, comment, subscribe on YouTube. Give me a review on Apple Podcasts and subscribe to the Substack, newcomer.co. Go try out Volley on your Alexa. Play Song Quiz, maybe. We're going to have a couple more episodes before Cerebral Valley. Cerebral Valley is on November 15th. We will publish our conversations to YouTube. We will probably publish them all. That's what we did last time. You can see the conversations from Cerebral Valley 1, which was on March 30th. And then, we'll play some of our favorites probably. We did a sort of distilled version in our podcast feeds, so follow the podcast feeds for those. And I'll be covering it in the Newcomer newsletter. So newcomer.co. Thanks so much.